Now let's continue on with mobile communication technology, starting with the IS-95 second generation digital cellular standard. Now, IS-95 stands for Interim Standard 95. Now, 95 comes from the year of release, which was 1995. And this was the first CDMA-based second generation digital cellular phone standard. And then comes the question, why CDMA? What's so important about it? Well, CDMA performs very well against narrowband interference and also multipath signal fading. Now, multipath signal fading is the phenomena where when you have a mobile phone and it sends a signal to the base station, or the base station sends a signal to your mobile phone, what happens is that there is a direct signal that comes quickest, and also the other signals will bounce off of the surrounding environment and arrive at you. It's something like an echo, and this is not good in a signal. We call this multipath fading because one signal pulse, one signal information is received multiple times a little bit later, something like an echo fashion, and this interrupts with the following symbol that is actually being received. So this is called multipath signal fading, and CDMA is very powerful to eliminate that and also eliminate narrowband interference. These are the good features about it. Now, CDMA1 is the brand name for IS-95 that was developed by Qualcomm. This was launched in 1995 in Hong Kong, and that was the first CDMA1 network. And IS-95 traffic channels support voice and data up to a bit rate of 14.4 kilobits per second, which is a significant improvement. Then comes third generation mobile cellular technology, and it comes under the name of Universal Mobile Telecommunication Systems. This is UMTS. It's an evolution of the original second generation GSM technology. And UTRA, which is UMTS terrestrial radio access, this supports several different terrestrial air interfaces. The multi-user access in UTRA can be supported by UTRA FDD or UTRA TDD. FDD is frequency division duplex. TDD is time division duplex. And these two can be supported. Then comes wideband code-division multiple access, wideband CDMA. And I've already talked about the benefits of CDMA. This is a wideband version of it. This is identified as a third generation mobile cellular system that uses UTRA FDD. The 3GPP, which is the third generation partnership project, released 99, the WCDMA specifications for mobile communication were up to 2 megabits per second of a data rate could be supported. And that was proven by the products that were actually sold and when people used them. First commercial WCDMA network opened in Japan in 2001. And seamless mobility for voice and packet data applications were supported. Quality of service differentiation for high efficiency of service delivery was enabled through this technology, and simultaneous voice and data support was enabled, meaning that while you're talking on your phone, you could use some types of limited data communication features as well. This interworks with existing GSM networks, which means that you originally had your GSM network, you could add on more equipment to it and then support the WCDMA mobile communications as well. Then CDMA 2000 became available, and 3G mobile cellular system, which was standard by 3GPP2, is this. It's an evolution of the IS-95 CDMA1 standard, and it uses CDMA and TDMA, where CDMA is the code division multiple access scheme, and TDMA is time division multiple access. This was initially used in North America and in South Korea, And the next evolution of CDMA 2000 was the 1X EVDO. And the EVDO stands for Evolution Data Optimized. It enables up to 2.4 megabits per second of a data rate, which was significant. And CDMA 2000 1X EVDO network launched in South Korea in January of 2002. It's regarded as the first third-generation system based on the ITU standards. Now, ITU is the International Telecommunication Union, and it is the specialized agency for information and communication technology of the United Nations. Now comes enhanced 3G mobile communication technology, and this is under the name of high-speed downlink packet access. This is an evolution of the UMTS technology for higher data speeds and capacity. It belongs to a bigger family called HSPA, High-Speed Packet Access Family Protocols, where, as you can see, the high-speed downlink packet access and also there's high-speed uplink packet access, and these type of technologies combine into the high-speed packet access HSPA family. Now, HSPA, which includes HSDPA and UPA, here HSDPA commercial networks became available in 2005, and the peak data rate included a downlink of 14 megabits per second, which was indicated in Release 5. Then comes EVDO Revision A. The peak data rate for downlink is 3.1 megabits per second. For uplink, it's 1.8 megabits per second. It was launched in the United States in 2006. And voice over IP support based on low latency, low delay, and low bitrate communications were now possible. In addition, there was an enhanced access channel MAC that was one of the features added to it. This decreased connection establishment time, so therefore connections could be established very quickly. In addition, multi-user packet technology was added, which enables the ability for more than one user to share the same time slot, and that makes it more efficient. In addition, quality of service, QoS flags were included for quality of service control. Now, there was Evolved High-Speed Packet Access, HSPA Plus, was introduced. HSPA Plus is an all-IP network first launched in Hong Kong in 2009. It uses WCDMA UMTS-based 3G technology enhancements. HSPA Plus is a HSPA evolution. The peak data rate for downlink can go up to 168 megabits per second. For uplink, 22 megabits per second. It uses MIMO technology, or they say MIMO or MIMO, which stands for multiple input and multiple output technology. This is a multiple antenna technique applied. And then comes the question, why MIMO? What's the big deal? Well, MIMO uses uncorrelated multiple antennas at the transmitter and receiver to increase the data rate significantly, while it uses the same signal bandwidth as a single antenna system. So the efficiency becomes tremendously better, meaning that if I was using a certain bandwidth on a certain single antenna system, by adding on MIMO technology, I used multiple antennas at the transmitter, multiple antennas at the receiver, then even though I'm using the same bandwidth, I can achieve much, much higher data rates using these uncorrelated multiple antenna technology. And that's what MIMO is, and that's why it's so good, and that's why the data rates were able to go up as shown right here. In addition, the higher data rate was accomplished by a combination of a couple of features. One was the MIMO technology, which used multiple antenna systems. That was the first one. The second one was higher order modulation. It used 64 QAM, technology. So every symbol was it included 64 internal symbols, and therefore it could send at much higher data rates. Then there's also dual cell HSDPA is used to combine multiple cells into one. And that technology also enables the data rate to go higher. Now, EVDO revision B. In this one, it was first deployed in Indonesia in January of 2010. And multi-carrier evolution of revision A is basically this revision B. It could accomplish higher data rates for each carrier, and the downlink peak was 4.9 megabits per second per carrier. And in the uplink peak, it was 1.8 megabits per second for each carrier. It had reduced latency using statistical multiplexing across these multiple channels. Now, reduced latency means reduced delay, and that results in an improved quality of service. Also, longer talk time and also longer standby time. In other words, the battery efficiency was improved on how the system was using the energy of the battery more efficiently. And that's, of course, a very good feature. In addition, hybrid frequency reuse reduced interference at cell edges and adjacent sectors. This is important because that's where we have our handover. That's where the performance is worst, at the edge of a cell. And also, if there's an adjacent sector or a cell, that's where interference becomes highest. Now, if you can improve your performance there, then that is wonderful. And this enables improved quality of service at the cell edge, which is a very useful feature. In addition, more efficient asymmetric data rate support is enabled by revision B. Now, asymmetric means that the downlink and uplink data rates are not equal. That's what asymmetric means. And there are so many asymmetric service examples that we use, like file transfer, web browsing, multimedia content delivery, and of course there's many others. And this asymmetric data rate support was more efficiently enabled in EVDO revision B. Now then comes LTE, long-term evolution. LTE launched in North America in 2010 with the Samsung SCH R900. It deployed on both GSM and CDMA mobile operators. So therefore, if you either had a GSM or a CDMA mobile operator, then these operators could easily turn their network to support long-term evolution, LTE techniques, by expanding their network services. So you could support the original one and LTE in addition to it. The peak data rate, based upon Release 8, for downlink was 300 megabits per second, and for uplink, it is 75 megabits per second. Now, we go into LTE-A, which is LTE Advanced, and considered as the 4th generation technology based on the ITU-R IMT Advanced process, which means that starting from LTE-A, we consider this technology as a 4th generation mobile communication technology. Now, the peak data rate based upon Release 10 for downlink is 3 gigabits per second. For uplink, it's 1.5 gigabits per second. And of course, a lot of users will share this overall peak data rate. And as you can see, it's significantly higher. LTE-A incorporates higher order MIMO, which is a 4x4 and higher orders. And using this, and also it allows multiple carriers to be bonded into a single stream. Using the MIMO technology and multi-carrier bonding, we can support higher data rates more reliably throughout the cellular area. These are the references that I use to prepare these lecture notes, and you can use them to study with more details about these topics. Thank you.